One of the processes Altshuler developed was based on analysis of contradiction that was seen to have been resolved in a patent. Altshuler categorized these, along with the principles used to resolve the contradiction, in a tool called the Contradiction matrix. This gives an indication of which of the 40 inventive principles are most likely to be useful in resolving the contradiction. This tool has been found to be very powerful in tackling a wide range of applications. The matrix is organized in the form of 39 improving parameters and 39 worsening parameters, with each cell entry giving the most often used inventive principles that may be used to eliminate the contradiction. This matrix is known as the Contradiction matrix and is one of the main TRIZ tools. The Contradiction matrix consists of a list of parameters so that the parameter that is getting better can be identified. In addition, the corresponding parameter that is getting worse can also be identified. The improving parameters are listed in the first column and the worsening parameter in the first row. In the corresponding intersection between the improving and worsening parameter, the table gives a list of principles that can be explored in order to resolve the contradiction. A 4-step process can be followed for using the Contradiction matrix. Use the 39 parameters to identify critical features in the problem. Identify the contradictions between the parameters where one causes problems with another. Use the Contradiction matrix to identify principles that can be used to resolve the contradictions. Use the numbers from the Contradiction matrix to look up resolution principles and use these principles to find solutions to the problem. The principles in the table for a given entry are listed in order of priority based on analysis of previous solutions. The principle most likely from experience to yield a helpful solution is listed first. If exploring this principle proves unhelpful, then the next principle in the list can be tried, and so on until a solution is apparent or options have been exhausted. The example of contradiction in the design of conventional axes for splitting wood was introduced earlier. If the blade is made heavier, it can strike a more effective blow with better splitting power. But the quantity of material used increases, making the device more awkward to handle. The improving feature in this case is force, and the worsening feature is the quantity of material. The corresponding feature numbers are 10 and 26 respectively. Examination can be made of the Contradiction matrix to identify which of the 40 principles are recommended. By identifying row 10 for force and column 26 for quantity of substance, the recommended principles are seen to be 14, 29, 18, and 36, corresponding to curvature, pneumatics and hydraulics, mechanical vibration, and phase transition respectively. The axe developed for the Fiskars brand makes use of a hollow handle to resolve the issue using the pneumatics and hydraulics principle. By using a hollow handle and replacing solid parts of an object with, in this case, air, the center of gravity is moved forward, and the effective blow from the axe becomes more powerful from a lighter tool. As well as applying TRIZ to technical and scientific challenges, the tool can also be applied to other domains. An analogy can be employed in transforming the technical terms to ones relevant to the domain concerned.